We move now to 3. That is the third method of solving quadratic equations by formula method. It is very easy to solve quadratic equations by formula method. Remember, not all quadratic equations can be solved by the method of factorization. We can solve them making use of the method of completing the squares or by the formula method. Let's take this down. Solving the quadratic equation, that is the general form of the quadratic equation, ax squared plus bx plus c equal to 0, by completing the squares. We treated this under completing the squares methods. We will obtain the quadratic formula. I'll write down the formula with a red pen. It is given by x equal to negative b plus or minus the square root of b squared minus 4ac. Then you divide all this by 2a. I will put the formula in the box. It's very important. You need to know this formula. Remember, we generated this formula under completing the squares method. Now we take examples. We are going to see how to solve quadratic equations by making use of this formula. Go solve the following quadratic equations by formula method. The first one, E, we have x squared minus 2x minus 8 is equal to 0. B, we have 6x squared minus 17x plus 12 is equal to 0. C, we have 5r squared minus 15r is equal to 0. D, we have 3y squared minus 5 is equal to 0. We take solution. We are going to make use of this our formula. So we are going to write using x equal to negative b plus or minus the square root of b squared minus 4ac all over 2e. So now the only thing we need to do is we just need to identify the coefficients. That is the coefficient of x squared, the coefficient of x, and the constant term, that is our a, b, and c, and we are going to replace them in this our formula. For question A, we have x squared minus 2x minus 8 is equal to 0. Comparing x squared minus 2x minus 8 equal to 0 with the general form of the quadratic equation ax squared plus bx plus c is equal to 0, comma, we have our e to be equal to, you see, x squared. So e is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 2. You take note of the sign. It is very important. And lastly, the constant term c is equal to negative 8. We are simply going to replace a, b, and c in our quadratic formula. Then we proceed with simplifications. X will simply be equal to negative b, put the negative, b is negative 2, plus or minus the square root of negative 2 squared minus 4e is 1 times c is negative 8. We have to divide all this by 2 times e, is 2 times 1. Negative here will give us positive. 2 plus or minus the square root of negative 2 squared gives us 4. Negative 2 times negative 2 gives us positive 4. Negative 4 times 1 gives negative 4. Negative 4 times negative 8 gives positive 32. Then we divide by 2 times 1, which gives us 2. This will simply be equal to 2 plus or minus the square root of 4 plus 32 gives us 36 all over 2. So this will be equal to 2 plus or minus, if you take the square root of 36, it gives you 6 all over 2. You'll see we have addition and subtraction, and we cannot be working with addition and subtraction at the same time. So it simply means either x will be equal to 2, you take addition first, plus 6 all over 2, or x is equal to 2 minus 6 all over 2. You remember a quadratic equation, when you solve it, you always obtain 2 roots. That means 2 solutions. So it depends on whether the solutions will be 2 real distinct roots, or repeated roots, or complex roots. Here, this will simply be equal to 2 plus 6 gives us 8 over 2. 8 divided by 2 gives us 4. Here, 2 minus 6 gives us negative 4 over 2. Negative 4 divided by 2 gives us negative 2. It simply means if we replace x here with 4, we simplify. At the left hand side, we are going to obtain 0. Or if we replace x with negative 2, we simplify, we are going to obtain 0. That's what it means. Now we go to question B. For question B, we have 6x squared minus 17x plus 12 is equal to 0. If we compare 6x squared minus 17x plus 12 equal to 0 with the general form of the quadratic equation, ax squared plus bx plus c, we are going to obtain our a. A is simply the equation of x squared, which is 6, or b is the equation of x, which is negative 17, or b is simply equal to negative 17, and our c is the constant term, which is 12. Now we are going to make use of our quadratic formula. We know x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. We are going to replace a, b, and c with their values in this our quadratic formula. So this will simply be equal to negative. We know b is negative 17, negative, plus or minus the square root of negative 17 squared minus 4 times E, which is 6, times C, which is 12. We have to divide all this by 2 times 6. This will simply be equal to negative gives us positive 17 plus or minus the square root of negative 17 squared is equal to negative 17 times negative 17, which gives us 289. Negative 4 times 6 gives us negative 24. Negative 24 times 12 gives us negative 288. We have to divide all this by 2 times 6, which is 12. This will simply be equal to 17 plus or minus the square root of 289 minus 288 gives us 1 all over 12. So this will simply be equal to 17 plus or minus the square root of 1 is 1 all over 12. It simply means that either x is equal to 17 plus 1 all over 12, or x is equal to 17 minus 1 all over 12. This will simply be equal to 17 plus 1 gives us 18 over 12. We simplify. 6 will go into 18 3 times. 6 will go into 12 2 times. This gives us 3 over 2. Or 17 minus 1 gives us 16 all over 12. 4 will go into 16 4 times. And 4 will go into 12 3 times. Therefore, x will be equal to 3 over 2 or 4 all over 3. So these are the roots of this our quadratic equation. Now we go to question C. For C, we have 5r squared minus 15r is equal to 0. Looking at this equation, you will see that 5 is the highest common factor of the coefficients of r squared and r. So it simply means we can divide all through this equation by 5, so that we put it in the simplest form. Divide 5r squared by 5 minus 15r divided by 5. This will be equal to 0 divided by 5. 5 will cancel 5 here. We will be left with r squared minus 15 divided by 5 gives us 3. R will be equal to 0. So we can write this quadratic equation as r squared minus 3r plus 0 is equal to 0. Next thing, we need to find the values of a, b, and c. Remember, a is the coefficient of the variable squared. That means r squared. The coefficient of r squared here is 1. Our b is the coefficient of r, which is simply negative 3. And our c is the constant term, which is independent of the variable r. Here our c is equal to 0. So now, by using our quadratic formula, we take note in this case, we are looking for r, not x. R will simply be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This will simply be equal to negative, we know b is negative 3, plus or minus the square root of b squared negative 3 squared minus 4 times e. Our e is 1 times our c, which is 0. We are dividing all this by 2 times 1. So this will simply be equal to, we know negative negative here gives us positive 3, plus or minus the square root of negative 3 squared gives us 9, minus 4 times 1 gives us 4, times 0, 0, all over 2 times 1, 2. This will simply be equal to 3 plus or minus the square root of 9 all over 2, which is simply equal to 3 plus or minus, we know the square root of 9 is 3, we divide all this by 2. So this will give us r to be equal to 3 plus 3 divided by 2, or r to be equal to 3 minus 3 divided by 2. This will be equal to, 3 plus 3 gives us 6 divided by 2, which is equal to 3. Or here this will give us 3 minus 3, which is 0, divided by 2. 0 divided by 2 is simply equal to 0. So these are the roots of that quadratic equation. R is equal to 3 or R is equal to 0. We go now to the last question, question D. We have 3y squared minus 5 is equal to 0. We can write this quadratic equation as 3y squared plus 0y minus 5 is equal to 0. We are doing so because looking at the quadratic equation, you'll see that the term in y is absent. Expressing the quadratic equation in this form, it will be very easy for us to identify the value of our b. If we compare this quadratic equation with the general form of the quadratic equation, we are going to obtain our a to be equal to the coefficient of y squared, which is 3, our b be equal to the coefficient of y, which is 0, and lastly, be equal to the constant term, which is negative 5. Now, by using our quadratic formula, y will be equal to, remember we are looking for y, negative b plus or minus the square root of b squared minus 4ac. Then we divide all this by 2e. This will simply be equal to negative 0 plus or minus the square root of 0 squared minus 4 times a is 3 times c, negative 5. We divide all this by 2a, 2 times 3. This will simply be equal to, we know 0 is a neutral number, so negative 0 remains 0, plus or minus the square root of 0 squared gives us 0. Negative 4 times 3 gives us negative 12. Negative 12 times negative 5 gives us positive 60. We divide all this by 2 times 3, which is 6. So this will simply be equal to, 0 plus or minus the root of this. 0 will be the same as plus or minus the root of 0 plus 60 gives 60 all over 6. Now the next thing we have to do, we have to express the root of 60 in the simplest form, because 60 is not a square number. If we take this 60, we know we can express 60 as the product of a square number and another number. We can write 60 as 4 times 15. 4 is a square number, 15 is not a square number. If we take square root on both sides, the square root of 60 will be equal to the square root of 4 times 15. This will give us the square root of 4 times the square root of 15. which is simply equal to the square root of 4 gives us 2 times the square root of 15. This will simply be equal to 2 root 15 because 15 is not a square number. Now we move back to our solution. This will give us y to be equal to plus or minus. Remember, root 60 is simply 2 root 15. We divide by 6. This will simply be equal to plus or minus. We know the highest common factor of 2 and 6 is 2. So 2 will cancel 2. We'll be left with root 15 at the numerator, all over 2 will go into 6 3 times. This will give us either, because we cannot be having a number which is positive and negative at the same time, either the number is positive or the number is negative. Either y is equal to root 15 over 3 or y is equal to negative root 15 over 3. So these are the roots of the quadratic equation. Now we are going to end by taking exercises for application. Remember, best learn mathematics by solving exercises. Equals solve the following quadratic equations. I will not oblige you to use a particular method, so you use any method of your choice. For question A, we have 2y squared plus y minus 1 is equal to 0. For B, we have 2 plus 2x minus 2x squared is equal to 0. For question C, we have 18 b squared plus 8b minus 3 is equal to 0. For question Z, we have 12q minus 9q squared is equal to negative 3. For question D, we have x plus 7 all over x plus 1 is equal to 2x plus 8 all over x plus 1. For question, this is question E, not D. We go now to question F. We have x to the power 4 minus 11 x squared plus 18 is equal to 0. Question G, we have 400x to the power 4 minus 389 x squared plus 81 is equal to 0. So in our next video, we are going to correct this exercise for application. So you do well to go through the exercises. Please like the video, share, and subscribe to this YouTube channel. Thank you very much for watching.